This is the third movie about the Aspire compilation toolchain, and in this part we will demonstrate the toolchain in action. Let's first look at the code we're going to protect. It's a very simple program containing basically only a main function and some very small auxiliary functions like the one you see here. And what you see in this program is that we've annotated a number of variables, and the annotation is actually, in this case it's done via macro, and the macro specifies that XOR masking should be applied to these variables. We also see that the code of the main function needs to be protected with obfuscation. So you see that we want to deploy branch functions and opaque predicates in this code. And then if I scroll down, you'll also see that in part of the code we have some variables, and we want to protect the variable dd1 with the barrier slicing technique that's used in client-server code splitting. So what you'll see is that dd1 is actually removed from the program, and that it will be stored on a secure server instead, and that the necessary communications will be injected into the program. Now let me compile this application with our toolchain, and you'll see that all the protections are deployed. So you see here the different source level processing steps. You see that different plugins are invoked and they produce various amounts of output. You see that code is compiled, then linked, and finally in the last processing step, binary level processing step 04, which for historical reasons is called obfuscate, but in fact this is no longer an obfuscation. This is the step where all binary level protection techniques are executed, and this step takes quite a while. The reason is that a whole bunch of communication libraries, or at least libraries necessary for the communication with the server, have been statically linked into the program. They were linked statically to prevent that attackers can observe the APIs and how those APIs are invoked. But as a result, of course, the binary has grown quite big. Now our binary processing will remove parts of the code that are not executed, but still the analysis of the code, the whole binary at link time, takes quite a while. Now let me scroll back to the beginning of the compilation so that we can have a look at all the passes. Here we are. The first thing you see is that a number of files were copied, 3 files in this case, were copied from the source directories to the build directory. Then some bookkeeping was done, and then the first step is, the first real step is pre-processing, and you see that all the C files are converted into pre-processed files. That's of course because most of the source-to-source rewriting tools that gonna inject the source level protections, they operate on pre-processed code. And you see one of the steps here is obfuscation, and you see that pre-processed file is converted into basically a pre-processed file with the obfuscations. So I can look at this file. Let me use Dolphin here. So I'm gonna go to this code and show you this file. Now this is pre-processed code, so you see lots of headers, but at the end you see the code of the application, and you see one pragma is still here. This is the pragma for barrier slicing and for the client-server code splitting. That's deployed only later in the tool flow. Also the pragma, you can see it probably in here somewhere for the binary level protection. This is also still in here, but you see that XOR masking has been deployed and all the XOR operations have been added in the source code. If I scroll down here, you see that later other transformations are applied. For example, here you see that at some point CodeSurfer is invoked. This is to analyze the source code. More complex analysis is needed to activate the client-server code splitting, and so this is done by means of CodeSurfer. And then after CodeSurfer has run and the results of the analysis are available, the actual transformations can be deployed. You see that happening here. Again, lots of output is produced. Eventually, after all the source level processing steps, there are many more, but they don't really matter for this use case. What you see is that the code is compiled, so the pre-processed and transformed files, like this license file, are compiled into object code. You see some compiler warnings here, but that doesn't matter. You see that we also compiled the Aspire client-side communication logic. So this is basically the library that's injected to talk to the server for the online protections. The binary is then linked, and as I said, a number of libraries are integrated. Now in this case you see that we immediately then step to binary level processing step 03. That's because 01 and 02 were not needed here. Those steps are only needed for a specific protection. So the program is basically relinked, and then we send it to the final step where, as I already said, obfuscations are applied, but also other protections. Here as well, from this one step, we can look at the intermediate results. If I go to this directory, you see here that we have various logs. For example, for the obfuscations, we have a log file that indicate that 7 obfuscating transformations have been deployed. You see on which function they have been deployed. In the case of opaque predicates, you see which opaque predicates have been injected into the program, and you also see the location at which they have been injected. So with this information you can inspect the original binary before the binary level processing and afterwards. We can actually also look at the specific transformations, what they have done. For example, the first transformation that was done, Diablo, the rewriter here, has generated 2 dot files. I'm not sure whether I can open them. Yes, it's opened automatically with xdot. So here you see, for example, the control flow graph of this function after the transformation, and I'll also open one before the transformation. I'm not sure whether the difference will be easily visible, but indeed you can see that the control flow graphs look different. If I zoom in here, you see that lots of information is available. If I go to the entry of the function, you see that this is a function that can be called externally. We call this calls from hell. That's because it's the main function, of course. You see all the instructions, you see the source line number, you see their addresses in the original binary, and so you can watch the whole control flow and actually study the points where before and after transformation the code differs. That's it.